There is happening a lot of studies about sun currently. Everybody is very curious to unroll the hidden details. Sun is mainly made of plasma. It has its own magnetic field, and there is something interesting about that. The sun's magnetic field is about twice as strong as the Earth's and much, much larger, extending well beyond the farthest planet in the solar system. NASA Goddard solar scientist Holly Gilbert explains a computer model of the sun's magnetic field. Getting a handle on what drives that magnetic system is crucial for understanding the nature of space throughout the solar system. The sun's invisible magnetic field is responsible for everything from the solar explosions that cause space weather on Earth, such as auroras. So how do we even see these invisible fields? First, we observe the material on the sun. The sun is made of plasma, a gas-like state of matter in which electrons and ions have separated, creating a superhot mix of charged particles. When charged particles move, they naturally create magnetic fields, which in turn have an additional effect on how the particles move. Solar flares are fascinating phenomena that occur on the sun, characterized by sudden bursts of radiation. These events usually arise from areas of intense magnetic activity and can range in intensity from minor to extreme. The classification system for solar flares includes categories A, B, C, M, and X, with X-class flares representing the most powerful and disruptive events. Typically, the sun experiences several flares each week. In May 2024, an extreme solar flare captured the attention of scientists and the public alike. This X-class flare, registering a peak intensity of 10.8.7, was one of the strongest recorded in recent years. Accompanying this flare was a coronal mass ejection, CME, a massive release of solar wind and magnetic fields from the sun's corona. 36 hours later, it triggered a geomagnetic storm classified as G5 on the NOAA scale, the highest level of severity. This storm led to spectacular auroras visible far beyond their usual ranges and caused notable disruptions in satellite communications and navigation systems. Some power grids experienced fluctuations, forcing engineers to protect the infrastructure. The May 2024 event served as a stark reminder of the sun's immense power and its potential effects on modern technology. As we continue to rely on satellites and electronic systems, ongoing solar monitoring becomes increasingly crucial. A geomagnetic storm disrupted ground-based communications, GPS accuracy, and satellite services, especially on the HF band. Power grids in Canada and New Zealand took precautions but avoided major outages. Some GPS-guided agricultural activities and drones were affected, while satellites like GOES-16 and Starlink experienced temporary service interruptions but remained mostly operational. The red region represents the warm temperature attained due to extreme sunlight in the equator. When the trade winds blows to the tropical region from eastern to western side, those winds pushes the warm ocean current towards the Asian side. The warm ocean current affects the surrounding atmosphere and it rises high into the atmosphere by convection process, and the clouds are formed and then it rains. The warm air travels to eastern part. Since the warm air travels through troposphere, it cools down, making the moisture content of warm air to loose and become dry. The dry air comes down to the Peruvian coastal region, making the region cold. This cycle is called Walker circulation. But when the trade winds are high, more rainfall could be obtained in the western region, called the La Nina effect. The La Nina effect could have been triggered more by the extreme solar activity in the month of May 2024. We could see an increment in rainfall from the month of June to July 2024. Due to extreme rainfall in Kerala, many lives and resources were lost due to floods and landslides.